Welcome to my YouTube channels. Today I am going to solve the shear force and bending moment diagram for the cantilever beam of combination of point load and UDL. So one problem I wrote here, a cantilever beam of length 2 meter carries a uniformly distributing load that is called UDL of 1.5 kilonewton. Run over the whole length. That means, so first we'll draw the cantilever beam means given diagram we have to draw the diagram. So I taken one beam. So it will take a small beam. Length will be 2 meter. So this total length will be 2 meter given. Now what the given UDL? Entire length. Run over the whole length. That means UDL the given in whole beam. Uniformly distributing load given whole beam. And what is the load the given? 1.5 kilonewton per meter the given. Length of a point load 2 kilonewton also given distance of the 0.5. So the given point load 2 kilonewton meter, 2 kilonewton the given point load here. The distance is 0.5 meter. A, B, then this point is C. Okay, so the given 2 kilonewton distance of 0.5 from the free end. From the free end. This is fixed end, this is free end. This is called cantilever beam. So they are asking find the SFBM, shear force and bending moment diagram. So okay, first we start the calculation, shear force diagram calculation. So at point B, SB, shear force will be 0. Why shear force will be 0? Because at the point B, no load acting. No load acting, the shear force will be 0. Then at point C, what is the shear force acting? So here see this, like this questions will be there. At point C na, we are taking CR na just right side of the point C. That means this point load will not come here. Point load will right, because R means just right side from the point C. So what is the UDL here given? 1.5 and into 0.5. 1.5 into 0.5, how much coming? That will be the answer, 0.75 kilonewton. 0.75 kilonewton. Because kilonewton meter and 0.5 meter, it will get the load SR. Now if you will see SCL, what is the meaning of this SCL? Now this 2 kilonewton also will come, just point C or left. R means just before this point C. Now what will come? 0.75 will be there SCR and that particular plus 2. So what is coming? 2.75 kilonewton. So this part you have to careful. Suppose this UDL is there and here one load is there. Point C. So CR means just after this C and CL means including, suppose this 2 kilonewton, include this CL means include this load also. UDL and point load we have to include in the L. R not just after the point. So only 0.75. This is the concept behind this. Okay. Now, any other point will be there? No. So directly we'll go SA. What is SA here? So what is SA here? Either directly you take this or direct load you calculate. This suppose 2.75 na up to there over, then again we have to calculate. This is little complicated. So directly what we'll do, entire length UDL is there, no? So first load 1.5 into 2, entire load and plus 2. So shear force only we are adding the load, either left side or right side. So 1.5 into 2 plus 2. If we will take 2.75, that means up to C point. From C point again we have to write 1.5 into 1.5 load, that multiply you have to do. Same answer will come. So here direct entire load UDL is there now. So that we can take entire load into 2 plus 2. So this will be the shear force at point A. So this calculation is coming, 5 kilonewton will come. 5 kilonewton. So how to draw now, you see. Extend this line, this also point load is there. Now, what is the sign conventions we followed here? This is the sign convention. Suppose this is the line. Now, what is this one? Downward force will be the positive right side, left side upward force will be the positive. Okay, this is the section. From sections right side, from we are taking right side, so we are taking right side, downward force will be positive. So draw the zero line first here. Then what is shear force at point B? 0. Then what is the 0.75? But this is UDL is there. UDL is there means shear force will be the inclined line. Draw the inclined line. Now again point load will be there. Point load with the sudden changes will be there. Sudden changes will be there. Again UDL is there. So just make this shorter. So inclined line will be there for A to C. How much? 5 kilonewton. 5 kilonewton. This point will be the 2.75 and this is 0.75. So what is this? This is sudden change. How much? 2 kilonewton point load will be there. So this is sudden load. So this is the shear force diagram for the given problem. Now we'll calculate the bending moment diagram. Calculations first, then we'll draw the diagram. You write here shear force diagram. So you make this line solid line and draw the H part. So this is the shear force diagram. Okay, now bending moment diagram calculations will take. Bending moment diagram calculation. So bending moment at B will be 0 because no force acting after the B. So force into perpendicular distance is moment, but in point B no load. So bending moment at B is 0. Now if we'll take bending moment at C, bending moment at C will take you see here at point C. So this will rotate 2 kilonewton. The 2 kilonewton will not come because taking C. So point 2 kilonewton acting at point C. So the 2 kilonewton moment will not come. So UDL what is 1.5 into load. We have to convert first. 1.5 into 5, this is load, kilonewton per meter into 0.5 meter kilonewton. And what is the distance? Half distance we have to take 0.5 by 2. This is the moment. And this will be negative because sign conventions you can write here clockwise. Clockwise will be the negative. Right side, left side anti-clockwise. ACW, this is clockwise, will be the negative. So we are taking from right side, moment taking from this point clockwise. So negative, so this will be negative. Answer will come 1.5 into 0.5, 0.5 by 2, 0.1875. 0.1875 kilonewton meter. This is the at point C. Now we'll take the moment about at point bending moment at point A. So what we'll get? So again we'll start from the beginning. See, entire length UDL is there. So first you'll take what is 1.5 minus you take, because from the sign conventions it will be the minus 1.5 into 2. Entire length will be 2 into 2 by 2 half distance. 2 by 2 half distance. Okay, take here square bracket because whole negative, no, so write inside plus. Then bracket, what is 2 kilonewton? 2 into, what is the distance? This one, 1.5. 1.5, bracket close. So this is the bending moment at C. So force into perpendicular distance, entire length UDL is there. So UDL first convert load, 1.5 into 2, this is load. Then what is the half distance? Because you know UDL having rectangular shape. So rectangle means center gravity will be the middle point. So 1 by 2. Or also I told the concept, you will draw the load diagram. If you will draw the load diagram for this UDL, what will become? Middle, suppose this is W is there, this is length L. So WL will be the load and L by 2. Once you will find the moment means what will come? WN into L by 2. So WL into L by 2. So 2 by 2. So this is the concept is there. Okay, this already support reactions we discuss a lot of time. Now what is the calculations this? What is the calculations coming for this? 1.22, so 2 into 1.5 coming minus 6 kilonewton meter. This is answer is coming. Now draw the shear force bending moment diagram. Bending moment diagram, how will draw? So bending moment at B 0, bending moment at point G 0. Now you have to check for UDL. For UDL, bending moment diagram for UDL is parabola. Parabola. So first one what is? This is 0 at point B 0. Now at point C, parabola. Draw the parabola at point C. Then again point C, point A. This also what is? Again you draw the parabola only at point C. This is called 6. This is point is coming 0.1875. So this is the, this little you draw like this, parabola. So this way we can draw the bending moment diagram. This way we can draw the bending moment diagram for given questions. So we'll check it once. So okay. So what we are observing here, two things you have to remember: how to draw the lines for shear force, for the UDL inclined line, for UVL. For UVL will be the parabola line if there, but now here only UDL is there. So inclined line in the shear force, and UDL for bending moment diagram is parabola. So this is the parabola, second degree curve. So this way we can calculate the shear force and bending moment diagrams. Okay. Okay, students, watch the video and watch the video beginning to end and subscribe the channel. Okay, thank you.